My name is Giacomo Incas, and I'm the project coordinator of the Easier project. So I'm part of Martel Innovate, which in Easier has the coordination role and also the communication and dissemination leadership. While for sure the biggest technical challenge of the project is improving the translation algorithms for going from sign language to text or speech and from speech to sign language. So both ways it's quite complicated because we have one direction and the other one. So in one direction, you have to look at the video of the person signing and make it possible that you translate it in writing by video processing and via machine algorithm. And the other way around, you have almost the same complication plus the rendering, which is from the text, how do I animate a virtual signer that is able to reproduce sign language. So both directions are really challenging. So when you think about how sign language is transferred from a person captured by a camera into the computer, you have to do some abstraction work. So the first thing is that the camera is capturing your image. Now, after that, there is a software, machine learning algorithm that extract from your image some key points. For example, a body is represented by 18 points that you can then transfer into the machine, and based on these 19 points of the body, and then for example we have like hundreds of points for the facial expressions. You may even have like other 19 points for one end and 19 points for the other end. So this gets abstracted from the image, and at one point this becomes values in the computer. And then what you do, you take these values and you make sure that you create a database where these values correspond to a certain text. So you do this matching. So, and this is a purely human work. So there are annotators that look at the image and try to assign to this image, this video, the correct text, so that the machine can understand that this text boils down to this image, which is represented by these parameters. And at one point, it does this match for all the samples you give them. And then at the very end, you have the translation system, thanks to this work of learning from examples. That the way we have to deal with the fact that we may have not perfect like subject, verb, object, or like some error sentences is it goes to the way that the automatic sign language translation algorithms are working. So they are working not as they are not looking at the position of this verb, of this object, of this subject, but they look at the examples and how we are providing them examples. So we generally, since sign language is not as structured as spoken language, what we do, we provide examples of full sentence in sign language that corresponds to a video. And in that sense, we can let the machine learn not just based on single sentence or a single piece of the sentence, but on more like broader. So it's these algorithms, they reflect more the way sign language is produced. And that's help us in having translation. And about the errors, what the machines are doing, they are learning by examples. And at the very end, what they do, they give you an approximation. So they look at the examples, they look at your input, and they say, okay, these inputs, it's like to this, which percentage. Now, if you get an input which is blurred or biased, then you get less confidence. So you get not 100%, not 90%, maybe 50% of results. So, and that's the way the machines are trying to couple with all these variations and errors. So the problem with people that are not producing sign language in a very accurate way, because they are not very familiar with sign language, or they are just learning sign language, is the fact that the machine is learning by examples and is trying to provide a result which is as close as possible to these results. So in a nutshell, if you are not very fluent in sign language, the machine will try to to see how close you are with the examples that are given. So in that sense, it's very handy. So the machine doesn't understand that you are producing not very fluently or that there might be some mistakes, but it's trying to tell you, look, this is more like a house, or this is more like this sentence, so that you as an end user, you may understand that maybe something is not very correct, but the machine cannot correct this for you, because it's only based on the example that the human are giving to them, and then it does an approximation. So what I believe towards the universal communicator between sign language and spoken languages is that it will take quite some years to get there. So the example that I always make is that we are now from sign language to spoken language like we were 30 years ago for spoken language to spoken language. So we are at the very beginning of our way to the universal communicator. But thanks to the technology and the machines that we have today, and if we provide more data and more annotations and better data, then maybe in 30 years we get almost the same results, maybe a bit less because it's more complications, but I think we should continue working, and the easier project is very good towards this path. I'm not working in sign language translation technologies for a long time right now, but since the very first time I fell in love with this word and with these technologies because they are challenging and I like challenges. And what I personally believe that if you continue investing time and money on these technologies, we may reach a better society and a better communication among all the individuals, all the citizens in Europe. And in particular, it's a very good effort that the European Commission is putting in funding these projects. So I was the coordinator of Content for All before now, and the coordinator is here. And all these projects, one after the other, they are building one on top of the other. So at every time is a little bit that you add, and at the very end, with all these drops, you build an ocean.